Okay, now it's getting a little bit uglier. We have a over x plus y plus m over y over x over a plus m. Again, mentally, I'm identifying my main fraction bar right here. So if I write down my problem as is, so parentheses a over x plus y plus, and then I have m over y over x over a plus m. Okay, there's my fraction, all broken apart in pieces. I'm going to recommend that you leave a little gap. I didn't do that initially, but if you leave a little gap on your paper, because you're going to be multiplying this and this and this by something, so if you leave some space over here to allow yourself to write some stuff there, your work won't get so garbled up and hard to read. So, looking at the least common denominator of this thing, LCD, x plus y is not the same as y, which is not the same as a plus m, right? This y is the same as that y, but that y is attached to that x, so x plus y represents a type of factor. Y is a type of factor, and a plus m is a type of factor. That's the least common denominator of the fractions. That's what I need to multiply by. So when I do that, I'm going to multiply this times x plus y times a plus m. And multiply this times x plus y times a plus m. And multiply this times x plus y times a plus m. All right. End result again. The least common denominator represents a whole number structure. It's in the numerator. Each fraction has a denominator we want to get rid of. So if my fraction bar is here and my plus sign's here, and we look and see what's left over from each thing, x plus y cancels x plus y. I'm left with a y, an a plus m, and an a. I recommend putting any monomial pieces in front. Since multiplication is commutative, we can go in any order we wish to. It's easier to put all the single objects in front of the parentheses there. The second object here, the y on the bottom cancels the y on top. This y all by itself, not the y attached to the x. Okay. Then we're left with m being multiplied by x plus y and a plus m. And on the bottom, a plus m is going to cancel a plus m, leaving me with an x and x plus y and y. Again, single object terms, x and y together in front, times x plus y in the back. That is the correct answer, but it's not finished because we can still simplify it. Okay? If you are currently looking in the back of the book to verify your solutions, that's where the back of the book stops. If you're currently looking at the odd number problems in the back of the book and showing absolutely no work whatsoever and writing down that answer right there, I know you're copying out of the back of the book. You're wasting both of our times. All right, so please stop doing that. But anyway, that's a discussion for a different time. To simplify this, basic distributive property, FOIL first, then the distributive property. For me personally, on this one here, I like to conserve space in my paper. I would probably FOIL this right above here. X times a is ax, x times m is mx, a times y is ay, y times m is my. That's still being multiplied by that m right there, right? FOIL is what it always has been. First, outside, inside, last. So do all four multiplication to get your four terms. So now, getting this final answer, hopefully, maybe we're done, we'll see. If I do ay times a, I get a squared y. If I do ay times m, I get plus amy. If I do m times ax, I get plus amx. M times mx makes plus m squared x. Same letter happens, we change the power. M times ay is plus amy. And m times my is plus m squared y. And all that goes over x squared y plus xy squared. Looking at that, does that look good?
No.
Anything else we can do?
Not quite.
Okay.
There's two A and Y's.
Got two Amy's there, right? You might notice I put everything in alphabetical order. That's not a requirement. But if everything's in alphabetical order, it's much easier to see if like terms happen. All right, so if this was YAM and that was MAY, there's all kinds of words you can make with yam, may, amy.
Yeah.
All right, anyway, but if it was any other order, they're still like terms. But if you put them in alphabetical order, it's much easier. Amy, Amy, they're the same. Amy, Amy, or samey, right? So, a squared y plus 2AMY, because 1 plus 1 makes 2, right? Plus AMX plus m squared x plus m squared y all over x squared y plus xy squared. Once you combine your like terms, you can't do anything else. I expect your final answers to go to that level, because you know how to do the distributive property, you know how to FOIL, you know how to add like terms. Everything I did from this point on down, you know how to do. So there's skills you already have, and the practice on those skills will make you better at algebra, so it's worth doing. So I expect every one of these problems that look like this to end up looking like this. Everything simplified on top and bottom completely, as much as possible. Do not stop at the parentheses phase.